Hello boys, I hope you all are safe and healthy. In today's video tutorial, we'll discuss about application on standard identities. Okay, so without much delay, let us straight away go to our video tutorials on application of standard identities. Today's topic is application of standard identities. Okay, today boys will be discussing on a topic application of standard identities. But before we go into the application of standard identities, let us quickly revise whatever we did yesterday. So in the yesterday's class, we discussed a couple of important standard identities. The first one being a plus b whole square is equal to a square plus b square plus 2ab. The second one being a minus b whole square is equal to a square plus b square minus 2ab, and the third one being a plus b multiplied by a minus b is equal to a square a square minus b square. Okay, a square minus b square. Okay, now these are the three important standard identities we'll be using in this particular exercise. Okay, so this is very important. You need to know all the three standard identities. A plus b whole square is equal to a square plus b square plus 2ab. A minus b whole square is equal to a square plus b square minus 2ab. A plus b multiplied by a minus b is equal to a square minus b square. Okay, now let us see some applications of these standard identities. Okay, now let us take an example directly from the book. So exercise 10.5. Okay, question number 2, Roman 1. Okay, the question reads as, using the identities evaluate the following. Using the identities, that means using any of the three identities, evaluate the following. So the first question is 81 square. Okay, now if you are to find the value of 81 square, you can directly find the value of 81 square as 81 multiplied by 81, because 81 square means 81 multiplied by 81. But as per this question, you are not supposed to find 81 square by multiplying 81 into 81. You have to use the standard identity. That means you need to break this 81 in the form of either a plus b or in the form of either a minus b. So let us see what will be easy for us. So can we write 81 as 80 plus 1? 80 plus 1 gives us 81. So 80 plus 1, then the whole square. So the square comes here as it is, and 81 can be written as 80 plus 1. Now this comes in the form of a plus b whole square. So 80 takes the value of a and 1 becomes the value of b. So this is in the form of a plus b whole square. So which identity will we use here? Which identity is coming fit here? The first one, a plus b whole square is equal to a square plus b square plus 2ab. So which identity is coming fit here? A square plus b square plus 2ab, right? So let us find the value of 81 whole square using the identity a plus b whole square. So 80 plus 1 whole square is equal to a square plus b square plus 2 into a into b. Our a is 80 and b is 1. A is 80 and b is 1. So a square plus b square plus 2 into a into b. Okay, now we just need to solve here. So 80 square will be 80 into 80. So let's square this. So 8 square is 64, and then 2 zeros for the square here. 1 square is 1 plus 2 into 80 is 160, and 160 into 1 is 160. So this will give us 6400 plus 160 plus 1, 161. So we need to add this 6400 plus we need to add 161. So this will give us 1656561. Okay, so what is the answer for 81 square? The answer for 81 square will be 6561, as we have got here 6561. So 81 square will give us 6561. So here, what application are we seeing of standard identities? So we are seeing that a plus b whole square is equal to a square plus b square plus 2ab. So this is the application of this standard identity. Okay, I hope you are clear with this. Now let us take one more example. Okay, let us take one example wherein a decimal point is involved. Okay, so this would be question number 2 Roman 5. Okay, the question is 6.1 whole square. 6.1 whole square. So in the previous we took a sum which we have wherein we had a plus b whole square. Now this is something again you can use as a plus b whole square, or you can use as a minus b whole square. Okay, both will be fine. So how can we write 6.1 as? 6.1 can be written as 6 plus 0.1 whole square, because 6.1 is 6 plus 0.1 will give us 6.1. Okay, let us verify this in the rough work. So 6 means 6.0 and 0.1. So if we add it up, what do we get? 1. So 6.1. So 6.1 can be written as 6 plus 0.1. So 6 plus 0.1. Now this is also in the form of a, and then this is b, and then we have a square here. So this will be given by a square plus b square plus 2ab. Okay, let us see how do we go about it. So 6 plus 0.1 whole square is equal to a square plus b square plus 2 into a into b. Okay, we just need to evaluate from here. Now 6 square is 36 plus now 0.1 whole square. So how will you find 0.1 whole square? You need to multiply 0.1 into 0.1. So let us work it out in our rough work. 0.1 into 0.1. So 1 1 is a 1, 1 0 is a 0, multiplied by 0 1 is a 0, 0 is a 0 is a 0. Then we add it. So 1 0 0. So decimal point after how many numbers? 2 numbers. So 1 2. So what answer we are getting? 0.01. So 0.01 plus 2 into 6 is 12 multiplied by 0.1. So this is equal to 36 plus 0.01 plus now 12 into 0.1. So let us work it out in our rough work. 12 multiplied by 0.1. 12 multiplied by 0.1. Okay, 1 2 is a 2, 1 1 is a 1, multiplied by 0 0 2 is a 0, 0 1 is a 0. Then what we do, we add it up. So this gives us 2, this gives us 1 0. Decimal point after how many numbers? After one number. So 1.2. So this will give us 1.2. Okay, now this is 36 plus, now let us add the decimal parts first. So we need to add 0.01 and then we need to add 1.2. We need to add. So this is a vacant place, so we'll put a 0 here. So 1 plus 0 is 1, 2 plus 0 is 2, decimal point here, and 1 plus 0 is 1. So 1.21. So this gives us 1.21. Now this is equal to now 36 plus 1.21. So 36 after decimal point, how many numbers do we have? We have 2 numbers. So we will write 2 zeros here, because 36 means 36.0 or it means 36.00. Why are we writing 2 zeros after decimal? Because there are 2 numbers after the decimal here. Plus 1.21. Okay, we'll add it up. 1 plus 0 is 1, 2 plus 0 is 2, 0.6 plus 1 is 7, and then 3. Okay, so 37.21. So what would be 6 plus 0.1 whole square? This would be 37.21. So this would be our final answer. Okay, so we have seen yet another application of a plus b whole square. Similarly, you will get questions wherein you have to use a minus b. Okay, so the a minus b I will give you as your assignment. Okay, so your assignment would be question number 1 Roman 2. 1 Roman 2, the question says 97 whole square. I'll just give you a hint of how you can do 97 whole square. So 97 whole square can be written as 100 minus 3. What is 100 minus 3? 100 minus 3 is 97, and then you put a square. So your 100 is your A and your 3 is your B. So this will be in the form of A minus B whole square. So you need to use the identity of A minus B whole square. Okay, so question number 1 Roman 2 would be your assignment. Another question we have, question number 1 Roman 3. 1 Roman 3 is 105 whole square. Okay, so how can we express 105 whole square? 100 plus 5 whole square. Okay, 100 plus 5 gives us 105. So this will be your A and this will be your B. So this is in the form of, the previous one was in the form of A minus B whole square, and this is in the form of A minus B whole square. From here onwards you will use the standard identities and you will try to fetch the answer. Okay, now the next question we have 1 Roman 4. 1 Roman 4 is 997 whole square. Okay, now how will you evaluate 997 whole square? Using standard identities. So 997 can be written as 1000 minus 3. So 1000 minus 3 would give you 997 then whole square. So this is also in the form of A minus B whole square. So you use the standard identity of A minus B whole square, and that will give you the answer for 997. So question numbers 1 Roman 2, 1 Roman 3 and 1 Roman 4. So these three questions will be your today's assignment for one of the application of standard identities. I have given you the hint. You can take the help of this and you can try to evaluate. Okay, now we come to the next question, the next type of standard identities. Okay, so in the previous class we dealt with three standard identities: A plus B whole square, A minus B whole square. So we have seen the application of these two, but the third one is left over. So let us see where and how do we apply this A plus B into A minus B is equal to A square minus B square. Okay, so let us quickly go ahead and solve a question wherein you will see the application of A plus B into A minus B. Okay, for this I will take a question number 2 Roman 6. 2 Roman 6. So these are all from the same exercise 10.5. Okay, 2 Roman 6. The question says, using the identities evaluate the following. That means 496 multiplied by 504. Okay, we need to find the value of this. So we can find the value of this by either physically or conventionally multiplying this 496 into 504, but you are not supposed to multiply and get the answer. You are, according to the question, you have to use the standard identities. Okay, so let us see how do we go about it. So we take the first term 496. So 496 can be written as 500 minus 4. 500 minus 4 gives you 496. Okay, now we take the second term 504. So 504 can be written as 500 plus 4. So 496 is 500 minus 4. 504 can be written as 500 plus 4. Now 500 the same number, 4 the same number. That means if 500 takes the value of A, if 4 takes the value of B, then this will also be A and this will also be B. Sorry, this is minus, so this is A minus B and this is a plus b. So is it in the form of a minus b multiplied by a plus b? So what is the formula for a minus b into a plus b? This is a square minus b square. Okay, so let us see how do we go about it. So 496 multiplied by 504. So 496 means 500 minus 4. 504 means 500 plus 4. Okay, so this is a minus b multiplied by a plus b is a square minus b square. So a square minus b square. So what is 500 square? 500 square means 500 multiplied by 500. So 5 square will give us 25, and 2 zeros, how many zeros will it become? It will become 4 zeros. Minus 4 square is your 16. Okay, so 20, so this is ones, tens, 100, 1000, 10,000, lakh. So 2 lakh 50,000 minus 6. Okay, you just need to subtract this. So 250,000 minus 16. Okay, so what will this become? This becomes 4, this becomes 9, this becomes 9, this becomes 9, and this becomes 10. So 10 minus 6 will give us 4, 9 minus 1 will give us 8, this will be 9, this will be 9, this will be 4, and this will be 2. So what is 496 into 504? This is equal to 500 minus 4 multiplied by 500 plus 4, which is equal to 249984. Okay, so this gives us the answer for 496 into 504. Okay, I hope things are clear. Okay, now let us take one more example. Well, I'll not solve the entire thing, I'll just do the first few steps for you, and the rest you'll try to do it as your assignment. So you can treat this as your assignment as well. Okay, so question number 2 Roman 7. Question number 2 Roman 7. 2 Roman 7, 205 multiplied by 19.5. So sorry, it is 20.5 multiplied by 19.5. So how can we write this in the form of a plus b into a minus b? So 20.5 can be written as 20 plus 0.5, and this can be written as 20 minus 0.5. So 20.5 as 20 plus 0.5, and 19.5 as 20 minus 0.5. Okay, so this is a, this is b. So a plus b multiplied by a minus b. So you use the same equation. Yeah, a minus b multiplied by a plus b is equal to a square minus b square. Okay, so this I'll leave it up to you. So question number 2 Roman 7, have done the first step. So from here onwards you follow the same process, and that will fetch you the answer. Okay, right, let us take one more question. One more question. We have question number 2 Roman 8. Question number 2 Roman 8. Okay, the question says you have to find the value of 9.6 whole square. Okay, so how can we find the value of 9.6? So 9.6 can be written as 10 minus 0.4 whole square. So which identity will we use? Which standard identity will we use? So it's just looking at this, is clear that is in the form of a minus b whole square. So this is in the form of a minus b whole square. So you'll be using a square plus b square minus 2ab. Okay, so this also I'll leave it up to you. I have done the first step, and then from here you carry on. So this question is exactly similar to question number 2 Roman 2. I have already done question number 2 Roman 2, so you can take the help from there. Okay, so your assignment for today, which I have already written down, your assignment for today will be question number 2 Roman 7, question number 2 Roman 8, and question number 1 Roman 2, question number 1 Roman 3, and question number 1 Roman 4. So please try to work out these as your assignment, and then you can, after completing this, you can take a snapshot and you can email me your assignments. If there's any doubt, you have my WhatsApp number. You can always contact me on my WhatsApp number. So I hope this video was helpful for you. So I'll again be back with another video wherein we'll discuss some more application of standard identities. Take care. Bye for now.